Euclidean geometry, the proof of the theorem of opposite angles of a cyclic quadrilateral. This theorem says that given a cyclic quadrilateral, that means a quadrilateral with all four vertices on a circle, then the opposite angles of such quadrilateral add up to 180 degrees. Let's do a bit of a background first to enable you to be able to learn it a bit more easily. So theorems are built on previous theorems and definitions. So what can we use at this stage? We have the theorem, angle at center of a circle, which says that the angle subtended by the arc of a circle at the center is twice the angle subtended by the arc on the remaining part of the circumference. And that's as far as we need to go at the moment. We will need a couple of previous more elementary theorems. To use the center, notice because we're using angle at center, to use the center, we need to join to the center, otherwise it's meaningless having a center there. So we'll join B and D to the center. And that means that angle there subtended by this arc is twice that angle there subtended by the same arc. And that angle subtended by this arc is twice this angle subtended by the same arc. That's 360 degrees. And remember, twice this, twice that means that those add up to 180 degrees. Let's get to the proof. We go straight to required to prove. We don't put given because we're not showing anything in the diagram. We don't have anything in the diagram that cannot be shown. We only need the given if we need to say something like O is center. But in this case, we're not going to have that because we need to introduce the center. Required proof. Remember, required proof actually interprets the theorem into this diagram. So while the theorem says opposite angles of cyclic quad are supplementary, we're going to prove that A plus C, which are supplementary, are opposite angles, are supplementary, and B plus D are supplementary. So that's the whole idea about required to prove. Now remember, originally we spoke about needing a center, so that's going to be a construction. So our construction, join B and D to center O. That's a nice brief way of saying it. There we are. And I've numbered 1 and 2 to make it easier to refer to the two different angles there. Proof. Now we're going to use angle at center. So O1 is twice A. Reason? Angle at center. O2 equals twice C. I could have put similarly, or I could just put angle at center as well. So, but now we know that O1 plus O2, if we look at that, that's a full revolution. A full circle is equal to 360 degrees, angles at a point. Therefore, it means that twice A, because twice A is equal to O, and twice C, because twice C is equal to O2, so I'm substituting twice A for O1 and twice C for O2, equals 360 degrees. Some algebra, take out a common factor, and we end up with A plus C equals 180 degrees. Now we still need to prove that B plus D equals 180 degrees. And there are a couple of ways of doing it, but the easiest way is just to use the fact that the angle sum of a quadrilateral is 360 degrees. So B plus D must be what's left of the 360 degrees, which is another 180, angle sum quad.